All right. Welcome to this last session of the day. This talk is called Attack Surface Reductions for the Adventurous Admin. Are you all still awake? Bit of livelihood still yet? Okay, it's good. It's good. All right. As I said, this talk is called Attack Surface Reductions for the Adventurous Admin. For anyone who may feel misled by this has nothing to do with the exploit guard feature called Attack Surface Reduction Rules. This has something to do with actually reducing the attack surface in your enterprise network. If you've seen me talk before, you know that I love kind of letting my curiosity lead me down deeply technical paths. This is not going to be one of those talks. This is going to be a soft talk. We're going to talk a little bit about my philosophy to security engineering. I have been coming to this conference for, I think this is the fourth time. I love it here. It's the best conference in the world. And we always have interesting discussions in the hallway sessions, in the sessions themselves. We talk about PowerShell, we talk about its application, we talk about DevOps. It's always interesting, but some of the most interesting talks I've had with people at this conference is after hours when we go have a beer and we start talking about, so what do you do in your daily life? And for the last 5-7 years, my kind of primary focus professionally has been security engineering rather than PowerShell and automation. But PowerShell also kind of plays a role in pushing that forward. And so multiple people have asked me, can you talk about some of these things you do, some of this Windows security engineering stuff, because that sounds pretty interesting as well. So we're going to give that a go, and we're going to see if that's interesting as well. Sound good? All right. So the agenda for today, I'm going to cover like very briefly where I'm kind of coming from. I'm going to cover the principles of what I call pragmatic security engineering. This is not like a widely dissected concept or a manifesto I've written or a big report that comes out every year. This is just kind of my primary philosophy and approach to Windows security engineering. We're going to talk a little bit about what brings down enterprises and what you can do to prevent that. And then we're going to have a look at two solutions or two tools that that me and my colleagues have implemented over the last couple of years and kind of the impact they had. So, where am I coming from? Has anyone heard this kind of allegory, the pet shop versus the cattle farm, in the context of kind of DevOps or automation at scale, right? So the idea is that in traditional IT ops and IT management, we kind of treat our servers as pets, right? We give them funky little names. You know, this is Bilbo the Hobbit. That's our mail server, stuff like that. And people start attaching emotions to these servers, right? And they start, oh, I don't want to decommission it. Yeah, but it's end of life. Like, get rid of it. But it's Bilbo the Hobbit, right? Nobody wants to kill a Hobbit. And so what we want to move towards is moving away from this kind of pet shop mentality and to the cattle farm mentality, right? Any animal gets an identifier, and it's kind of just a ruthless capitalistic processing of nodes throughout your network, right? So when people ask where I'm coming from, right now I work at a big Fortune 500 company, but I used to work in the hosting industry, and I used to work third-line support for big enterprise customers. We had a lot of big enterprise customers, and so what I would describe that experience as was I was kind of managing a petting zoo, right? We had all of these customers who they would like to treat their own servers as little hobbits, as little pets. And sometimes we kind of got through to some of the bigger customers we were working with. If you want to do this at scale, if you want to do this efficiently, you need to approach server ops and server management a little differently. But it's kind of a mixed bag. So during the first 5-6 years of my career, I got exposed to kind of a large number of different enterprise setups with different requirements, anything from 5 users up to 500,000 users in some of the biggest corporations I was working with. And so you see a lot of stuff when you have that kind of exposure to different environments. And I saw a lot of the same stuff, right? Like I saw a lot of people making the same mistakes over and over again. And it took me a long time to kind of figure out how to address some of these problems. And so what I've kind of developed over the last couple of years is what I call pragmatic security engineering, and it kind of boils down to 3 completely non-technical kind of rules of thumb. And so the principles of pragmatic security engineering to me is, first of all, you need to engage with empathy, and we're going to talk about what that means. The next is that you need to focus on kind of your own personal, but also your environment's transition from a disabler to an enabler. And then finally, kind of using that, refocusing on understanding actual risk and opportunity in the environments that you're trying to secure. So, okay, that's a bunch of text. What does that mean? Engaging with empathy, and I can't spell engage, I can see. Get comfortable talking to your customers or to your users, right? I've seen this in security departments, I've seen this in ops departments, I've even seen this in help desks, right? Where, users are losers. We don't want to engage with them. We'd like to interact with them as little as possible. And if they're doing something wrong, they must be the idiots, right? This is almost always incorrect, right? Just like when we first had the discussions about what is this DevOps thing good for, like, can't we just treat Dev and Ops in two different silos? No, it's kind of the same thing, right? If you're working for the same company as an end user who's not necessarily technical, you're still on the same mission, right? We're trying to fulfill the same goal. So get comfortable talking to people. And I know this can be daunting for some in IT. It used to be daunting to me for a long time, but the results will speak for themselves. So I highly encourage you to just go out and talk to people. So what do you talk to people about? What do you talk to your users about? Well, one of the questions I like to ask when I engage with someone the first time is, what is your mission, right? What is your purpose? What are you trying to achieve here? How are you trying to achieve it, and why? Not just why are you trying to achieve a certain thing, but why do you think that this is the best way of trying to achieve that mission or that goal? If you can engage in that sort of conversation with your users or with your customers, with your stakeholders, with your manager, it doesn't matter who, right? If you can engage in that conversation, all of a sudden you'll find that you have a lot more to bring to the table in terms of pragmatic solutions, right? The second point is kind of transition from disabler to enabler. Has anyone seen this Dilbert comic before, or this Dilbert character, Mordak, the preventer of information services? Right. This is kind of the classical take on the information security guy in your corporation, right? He's just there to say no, right? And if you seem to be having too much fun or you're too productive, he'll come and find a way of making an end to that, right? So this is kind of the classical view of the security department, the security guy, right? They're just here to say, no, you know what, next time we spin up a project, we're not even going to engage with them. They can come back and scream at us later, right? So if you find yourself in a situation where you think your job is to say no to people, you're going to have a hard time very soon, because they will stop engaging with you, and all of a sudden they will start doing weird things. Shadow IT, we all know of this phenomenon, right? We're not there either as ops people or security people to solve a certain problem, and users are creative, right? They will find a solution, but they might also bring risk into the pictures at the same time. So what does this look like, right? As you can see, I have 3 pictures of 3 different security professionals here. You can see that on the tie they're wearing. I can kind of imagine myself in this role, and if we imagine that kind of the x-axis here is time, as I said, I used to think that my job was to say no, right? I was this guy. So a user would come and say, like, can we install this product? Can we configure this? Can we get this data channel? Can we get this file share? And I would say no, right? So over time, I evolved my thinking a little bit. And so I said, no, but here's why. I still thought it was kind of my job, kind of my primary role, to find a reason to say no, but at least be able to back it up with information so that they understood why I would say no when they came back next week and asked for the same thing. Then finally, I started trying this, right? So I was saying, sure, we can do this, but you need to consider these risks, right? For me, I was doing the exact same thing as before. I was still trying to find reasons to say no. I was trying to figure out how whatever the users were asking for or trying to do would change kind of the risk we were exposed to in the network or as a company or as an organization. But then at least I could say, yeah, sure. If you're comfortable accepting that this is a risk when we do X, please go ahead. And then finally, once you start taking that into account, you can start saying, here's what we can do instead. And once you start saying, here's what we can do, congratulations, you've become an enabler for the rest of your company, right? You're not the guy saying no anymore, you're actually the guy driving forward, and you maintain some level of control over what's going on, what's getting implemented, what kind of policies are being implemented how, right? Finally, we're not going to go into too much detail about this, but as I said, point 3 is like focusing on understanding risk and opportunity rather than industry buzzwords. And so thinking ahead in this space sometimes means that you need to stop buying solutions, right, and start solving problems instead. And so I think a lot of people who work in security engineering or ops have probably had this experience, right? They have a pretty good idea of the biggest problems that they have and that they need to solve, and they're trying to approach the CISO or the CEO to get budget to do what they think is right, and then all of a sudden the CISO or the CEO comes back from a conference and says, I got this really good sales pitch, right? Like, it's only going to cost us $16 million to buy the license this solution. You're going to implement it over the next 9 months, and by the way, this took up the rest of the budget, so now you can't do any of the things you wanted to do. This is maybe not what you want to hear, right? But if your CISO or your CEO is in a position where they've been told that this is the silver bullet, this is the panacea that will solve all of your problems, and you're not capable of having a conversation about whether that's likely or not, you're in a bad place, right? So every year, the national CERTs, right, the computer emergency response teams all over Europe and all over the world, they release reports about the incidents they've responded to, the developments and trends they've seen throughout the industries. And I guarantee you that if you go back through the last 5, maybe 10 years and read these reports about what are the biggest problems that they find in the companies that they're trying to help respond to, they're going to mention the exact same 4 things. And they will have mentioned them, as I said, in the last 10 years worth of reports. And so we're going to have a look at what those are. The first one, by far, is poor patching discipline. Right? You can solve some of this problem by, let's say, shifting some of your applications into the cloud, so you don't need to manage your Windows servers yourself. You don't need to think about are you disrupting a workload that's running on maybe not the most highly available system. But poor patching discipline in kind of my observations usually comes down to organizational issues. And this goes back to being able to talk to your users and your customers, right? If you start kind of a heavy-handed patching program where you force everyone's laptop to reboot all the time, you force all of their servers to reboot all the time, and all the applications go down and the databases disconnect, you're not going to be the most popular security engineer in your company. And so, again, in order to solve poor patching discipline, you need to engage with IT ops, you need to engage with business owners, and you need to engage with application owners about what does a nice patching schedule look like? How can we notify you in case there's issues? What does an acceptance test for a patch system look like, right? So again, not so much a technical problem as an organizational problem. And as long as we treat it as a solely technical problem, this is going to be number 1 on these lists of reasons that enterprises get breached, right? Right. Another one that comes up all the times, and some of you might be nodding and recognizing this, is that there are too many damn local admins, right? All over the place. You might say, okay, well, it's just one computer, right? The problem with too many local admins accounts, especially people who have explicitly been granted local admin permissions on, let's say, a Windows 10 device, is that end user attacks are all of a sudden way more effective, right? If I end up on a phishing site or something comes through the spam filter and I click an HTA file or an exe and some malware executes, if it's executing under my security context and I'm explicitly a local admin on that system, guess what? The malware is also an admin on your system. It's not your computer anymore. And so this is kind of obvious to a lot of people, but it's not always obvious how you can not necessarily solve the problem, but mitigate the effects of this problem. And so we're going to have a look at how you might be able to do that later. The second one, this shouldn't come as a surprise given the second one, too many domain admins, right? Too many administrators in identity management systems. Or generally treating identity management systems, be it Azure Active Directory, custom LDAP, Okta, whatever you have, kind of treating it as just another applications, right? Yeah, someone needs access, just give them the access. And so has anyone ever, how many people here are experienced with Active Directory administration? Right, so quite a lot of people have experience with Active Directory, right? Has anyone here ever accepted a job at what seemed to be a fine, nice company, started the first week and realized, holy hell, what a mess, right? Like nobody has taken this serious anywhere. Has anyone had that experience, right? Okay, so almost as many people as just raised their hands. So the problem with this, of course, is that there's an increased likelihood that breach of a local machine or local admin account leads directly to what attackers might call domain domination, right? All of a sudden, if I have control over your identity management system, you can obviously not trust anything more because everything else is kind of anchored in trust in that system in the first place. And then finally, and this is kind of a boogie word for a lot of people, is no application control in place, right? Application control, also known as application whitelisting, right? This ability to say we have a set list of applications and scripts and so on that we would like to run throughout our network, and anything else that tries to run, the computer should just stop it in its tracks, right? Effectively implemented application whitelisting is probably the best way to stop an attacker in your network in their tracks. But it's hard, right? We're coming back to kind of organizational issues here again. Do you know how many applications are running throughout your enterprise? Are they all properly licensed? Who knows these things? Are you collecting things like hardware inventories from SCCM? Are you reviewing the data that you may get back from Intune or similar systems? Are you forwarding events for new services, new applications being installed in your computers? And so, unless you kind of have these problems solved first, doing an effective and non-disruptive whitelisting implementation can be really hard. And has anyone here tried implementing AppLocker or similar? Was it maybe a bit of a pain in the ass, not necessarily the product, but the process? Right. Somewhat, right. At least somewhat. Okay. So, as I said, I want to dig into a couple of examples where we've kind of leveraged PowerShell to solve some real-world problems and mitigate some real-world risks. But before that, I kind of want to pay a little bit of lip service to things that you can do without a huge budget, right? So if you find yourself in a smaller company or in a large company where nobody wants to pay big bucks, there's a bunch of things you can do to kind of up your security posture. So this is kind of number one. Event forwarding, right? Did anyone see, there's a WEF talk earlier today? Yeah, so a bunch of people saw that. I would very much recommend, if you don't have any sort of event forwarding solution in place, that you go back and revisit that. Because I think Staffan said yesterday in his talk about memory-related performance that rule number one when doing performance optimization is measure, right? Rule number 2 and 3 happens to also be measure and measure. And so, in terms of security posture and your ability to either detect or reason about what's going on in your network, this is kind of the equivalent, right? Rule number 1, establish some sort of visibility in all of your endpoints, and the easiest way to do that in kind of your classical enterprise network is simply forwarding all the events. If you don't have the big budget for Splunk or any of these big log forwarding solutions, no worries, right? Windows comes with Windows Event Forwarder. It can be a little tricky at scale, but you can actually scale this up. We're using Windows Event Forwarding for around 20,000 Windows clients. And so, yeah, this is absolutely possible. ELK, Elasticsearch, Logstash, Kibana has a couple of free editions of their product you can spin up and kind of feed all of your data in there and start making dashboards and start pivoting on this data, right? Number 2, enable AppLocker in audit mode. As we just talked about, trying to enforce application whitelisting can be quite a pain both for you and your users. But if you enable AppLocker in what's called audit mode, what it's going to do is it's simply going to lock in the event log every single decision it would have taken had you enforced the rules that you have in place in AppLocker, right? So this can be a pretty good starting point for starting to assess okay, what would we need in an ideal rule set, right? And you don't need to do it for your entire company, right? If you have a business division where you say, okay, these people down here have a very clear-cut job, they only need 3 applications and a browser, start down there. Start easy, start small, show that it can be done, and then maybe you can get some buy-in from the rest of the organization, right? Again, start with the default rules and kind of tune in small iterations. Try to see if you can kind of find the biggest offenders in the most homogeneous groups of machines you want to apply this to. Another thing that you can easily do now that you have event forwarding in place is capture auto-runs and browser extensions and startup and logon. If we're talking about risk coming from users installing and running applications on themselves, kind of the browser footprint is becoming more pervasive, right? We're doing more and more in browsers. So collecting these kinds of things, you can use a simple PowerShell script to pick this up during startup, feed it back into your event log, and it'll automatically pop up in ELK or wherever you're collecting your logs. Deploy Sysmon, right? Anyone here using Sysmon? So we have a couple of people here using Sysmon, right? And Sysmon has been out for, I think, 3 or 4 years maybe. And so it's getting to a point where it's pretty stable. There's a lot of kind of intel out there, people who have experiences and who have shared these rule sets work for these products. This is how you can kind of approach it, right? So there's a lot of tooling and there's a lot of experience around Sysmon already. When I first tried to introduce this idea of deploying Sysmon in our own network, the immediate take was, well, what if we configure the rule sets incorrectly and we start logging a bunch of events for things that happen all the time but are actually benign? Isn't that going to have a performance impact? Well, again, go back and talk to the people who are worried about this, see what their actual concerns are, and then see if you can figure out some models for proper acceptance testing, involve them in kind of the Q&A of your Sysmon configuration. Again, kind of start small, test new rules in small iterations. All of this is just kind of applying DevOps to security engineering, right? Finally, review and deploy baseline configurations. There are plenty of organizations out there that, for free, put out their kind of recommended configuration of Microsoft Windows. They usually come in like a big XML package and maybe a tool. And so it's going to say, we would recommend if you're trying to comply with certain regulatory standards or so on, you need to set these settings. Go through the list. It'll be cumbersome, right? There's a lot of group policy settings that you can apply, but go through it and try to see, okay, what makes sense? What is relevant to the applications we have in the network? What is relevant to what we already have in place? Right. So with that in mind, as I said, I want to have a look at some actual tools that I've kind of tried to apply this mindset to and build in order to solve some problems. So the first one I want to talk about is something called Later. Later stands for Local Admin Temporary Elevation Request. And this has to do with basically supplying on-demand Windows local admin capabilities without investing a single dime in desktop management software. And so we had a very basic problem, right? And this will be this is probably recognizable to a lot of people. The problem was that we had many users, right? Many normal users with local admin privileges on their desktops or their laptops. Like, for an attacker, this is gold, right? Instead of figuring out which one user you can attack that has something useful on their laptop that you can maybe pivot on from, you could just attack anyone in this network, guess the password of any user, and now you have a local admin session on a desktop that a domain user can log into. And so this is gold, right? But it gets even worse, because many of these users who had been delegated local admin privileges on their laptops and their desktops, for kind of convenience and scalability on the help desk side, this had been delegated through shared groups in Active Directory. What do I mean by shared groups? I mean that we literally had groups that said local admins Department X, local admins Office Y. Now, this sounds super easy from a help desk perspective, or if you had to operate these group memberships, right? The problem with this is that anyone who is now a member of that group is now an admin on any machine in that entire department or that entire office, right? So you end up in a situation where if I can guess the password of one user in an office with 200 machines, I now have access to all 200 machines as a local admin. And so this is not very good. We need to do something about this. And so I've kind of been through this process at other customers, other companies before, and I kind of knew what to expect, right? Because the classic conversation goes something like this: you have your boss or your stakeholder who says, "We got this report. It's all bad. We're not the auditors are going to come after it. We need fewer local admins." So you say, "All right, I'll see if I can find the cheapest solutions. You can't have budget for that." Okay. Well, I'll just take it away from everyone via GPO, right? You have stuff like restricted groups and group policy. Let's just apply that. And so you go ahead and do that, thinking you're doing a good job, and all of a sudden help breaks loose, right? Like, what are you doing? Nobody can work. You're fired. This is not good. Okay, so what happened instead when we tried to apply group restrictions for local administrators? The immediate result was kind of as expected. Helpdesk started handing out Labs password. Is anyone here familiar with Labs or local admin password solution? Right? Great. If you don't have experience with this and you're managing Active Directory, I'd very highly recommend looking into rolling out Labs. But basically, the idea is that the group policy client on your machine takes care of changing the local admin password and then sends that back to Active Directory, so that you ensure that every single local built-in local administrator password on all of your boxes are unique. So that means that if I breach one box and I steal the built-in local administrator password, I can now no longer reuse it to log in to the rest of your network, right? So this is pretty smart. And so what happened when we took away these privileges or these group memberships is that people started calling up Helpdesk and saying, I can't do my work, or I can't install this application, or I can't do XYZ, right? And so Helpdesk had to hand out kind of the Labs password. Now, we accepted this risk because we had set the Labs policy to expire pretty quickly, right? So within a couple of days, the password would expire, and if anyone, if they wrote that password down right, it would only be valid for one computer for 3 days. So, okay, already way better than delegating local admin privileges to everyone in the entire office. But this was a pretty terrible user experience, right? Like, this is what our Labs passwords look like. I happen to work in a company that have offices all over the world, right? Try imagining two people speaking a company language of English, none of whom have English as their native tongue, trying to exchange that password over the phone while you're trying to log into a username you've never heard about on your computer, right? This failed all the time. People were super unhappy about it, and Helpdesk, they weren't too popular, right? And from a security point of view and from an anomaly detection point of view, this was also not an optimal solution, because we had a hard time correlating local admin actions with helpdesk tickets, right? People would get the password, they would log out of their own account, or they would start a process as the built-in local administrator. And we did get the events forwarded, but it's really hard for us to see whether this is legitimate or someone kind of brute forced the password or stole a session, right? There's no way for us knowing that, oh, they're actually on the phone with Helpdesk. We didn't have that kind of integration with the Helpdesk ticketing system, right? That's bad. So, okay. You're in this messy situation. What are you doing? We need to find a solution, right? So the solution was a little simpler than I immediately imagined. But I was talking to a consultant we had on site, and I had asked him to do something that involved PowerShell GEA. We're all familiar with PowerShell GEA, PowerShell JEA, right? So this ability that we can spin up a PowerShell endpoint on a machine in constrained language mode, and rather than you logging in as yourself, you can be granted access to log in and then perform actions on behalf of that system, right? So this is a pretty great way of delegating kind of privileged operations on a certain server or in a certain subsystem to a user without giving them domain admin or DNS admin or whatever you're trying to delegate. And so he was like, "Gee, I've never heard about this." And so I explained to him, and he was like, "Oh, that's cool. You could do some interesting stuff with that. What about that Labs self-service thing that you're complaining about? Can't you do that with this technology?" And I was like, "You're right. I could use PowerShell for this." So what we did is we spun up a Windows server, right? PowerShell 5.1. We deployed a single constraint endpoint, and then the only thing else we needed was access to Active Directory and then a queue or database of some sort, and you'll see why. So in this solution, the laptop over on the left here belongs to a completely regular, normal user trying to do their job, and they find themselves in a situation where they can't get on without local admin privileges. Maybe they need to install some application. Okay, what's the first thing that happens? They double-click a shortcut that we've placed on their desktop that basically says request local admin. This spins up a PowerShell WPF GUI with a single button. When they click the button, the PowerShell prompt connects to the PowerShell remote endpoint and requests the labs password for the machine that it's currently on. In the script, in the constraint endpoint, we attempt to fetch the password from Active Directory. If there's no password set, like if labs is not applied, we can fail immediately. Otherwise, we try to verify the requests. We have a look at PS sender info in this remote run space to see, is this a machine and a user for which we allow retrieval of the local admin password? So this way you can kind of more granularly say, oh, only these users down in Office B, down here, they're really important and they're installing software and updating drivers all the time. Only these should be able to do this for their own computers, right? Now that we've done that, we're going to log this request. We actually log it twice. We log it to the event log on the box, again, forwarding back into our ELK cluster or whatever else we have. And then we log it to a database or a queue. I think right now we're using Microsoft SQL, but you could replace this with a queue or any other database, and I'll come back to why that is. Finally, we return the password to the caller, and then the calling script launches another PowerShell script using the credentials of the local administrator password. This script forces a group policy update, and once it's forced a group policy update, it doesn't make the user a local admin. It puts something else into the local admin group, namely the nt-authority/interactive label. The reason for doing this is that now the user does not have to log out and log back in to get their admin privileges, because nt-authority/interactive is already injected into their security token when they do an interactive logon at the console of their machine. The reason we force a GP update is that if we reset the group policy client refresh interval, we have about, I think by default, 90 minutes. You can reconfigure this, but this gives us a window of 90 minutes before the restricted group policies kick in again. And so we're kind of hacking our way around only temporarily allowing the user to become a local admin without actually becoming a local admin, right? Again, we don't add the user to the local admin group. We add something that's already in their security token to the local admins group, so that the next time they spin up a process, they don't need a new security token. The next process will already have the /interactive flag in there. Finally, on the server side, we write back to Active Directory a new timestamp for the labs password, so we expire it immediately, right? This also mitigates the risk. Let's say that you've configured some of your machines to have a running time of 10 or 30 days. Well, you might want to expire it immediately because you kind of deliberately just leaked it to a user, right? So you want to mitigate the impact. Finally, the reason that we're locking secondarily to either a queue or a database, basically what we're locking is a hash of the computer and the user along with the username in clear text. And the reason we're doing that is that now we can start implementing throttling policies, right? So by the same time as we're trying to verify the request, we can go back to our Redis queue or our MySQL database and say, like, can you tell me all the requests that this user has made in the last 30 minutes, in the last 12 hours, in the last 24 hours? This way, we can kind of throttle abuse before it happens rather than reacting to it retroactively, right? So we can say, for certain parts of the business, you're only allowed to retrieve the local admin password for a maximum of 2 machines twice a day, or we can say, you know, you can do it more because we're expecting you to work on 10 different machines, right? Okay, so the final result of this, of making this change, was we're down to near zero burden on help disk, right? Nobody needs to call help disk and interact with another human anymore. They just click a shortcut on their desktop, and now they have local admin privileges, and it's going to go away again, and they don't need to worry about anything. The users are super happy about this, right? One click in a few seconds, great, and they don't even have to log back in. Events are easy to correlate, right? I said we log this to the event log on the box that facilitates retrieving the labs password. And so that means that we now have an event from our trusted subsystem through which you can retrieve the labs password that we can correlate with what's going on the endpoint itself. So we can expect 2 events on the endpoint itself, namely the built-in local administrator logging in, and then adding the interactive user to the local administrator groups. If we can correlate that with a single event, we don't need to cause any alerts, we don't need to investigate it further, our SOC doesn't need to do anything, this is all expected, right? Finally, and this is kind of the most beautiful part of the entire thing, we've reduced the attack surface of people having this requirement to have local admin privileges on their own workstations, because the user is not an admin. If I had stolen the password of that user and I used it to log in, let's say via WMI, RPC, WinRM to that same box, I won't get administrator privileges because that's a network logon, that's not an interactive logon. Now all you need to do is just make sure that RDP is disabled on all of your endpoints, and it probably should in the first place. The other thing is that if you steal the password of this user and we in Active Directory had delegated this privilege of being assigned local admin, again, I could now log on to any computer. Now we're contained to that single one box on which that request took place. So again, kind of the components that went into this, a PowerShell script with a simple WPF GUI, literally one button, right? This could be packaged in SCCM or in Intune or pushed via a group policy, a constrained endpoint configuration for retrieval of the password and accounting on the server, an account with read access to labs. Again, you could delegate this to the smallest possible subtree of users or computers that you need to give access to. And then finally, a database or a queue, right? Microsoft SQL Server, Express, or Desktop Edition, or whatever it's called, will do, right? You're probably not going to have millions and millions and millions of local admin requests, because if you are, you should probably be looking into why that is, right? So the other solution I want to talk about is a sort of ransomware mitigation that we put in place a couple of years ago. And I think this is interesting for a number of reasons. And I can see here that I managed to fuck up my slide deck. So, right. So anyone who's seen a talk by me know that I love historical context about the technical issues we're talking about. And so I'm going to give you a brief history of ransomware, right? So in 75 BC, the infamous dictator of Rome, later dictator of Rome, Julius Caesar, was held for ransom by Cilician pirates in the Aegean Sea. This is kind of the earliest. Known example of a celebrity kidnapping, if you will. And so this is, if you ever wonder about this ransomware stuff, this is where it started, right? It did not work out very well for the pirates that kidnapped and held him for ransom, because he said, sure, I'll send my men back to get you 20,000 coins of silver. And they said, oh, great, we got him. And so his soldiers came back, gave them the 20,000 coins. He sailed back to Rome, and then he came back and slaughtered all the pirates a week later. So yeah, okay, don't get into ransoming people or kidnapping them. This might happen. Okay, we're going to jump a little bit. In 1938, the Royal Navy bought Bletchley Park, and eventually MI6 invented modern cryptography, kind of as an extension of the war effort. We're going to jump a little bit again. In 1989, the World Wide Web becomes tangible at CERN, right? And we get kind of connected internet nodes between Europe and America, and this kind of explodes, right? So widespread widespread internet adoption kind of ensues in the following 5-10 years. And then finally, we jump forward to 2015. Your corporate printer is held ransom by a North Korean Bitcoin miner, right? So I think there's kind of a clear red thread between these events, right? So how did this impact me? How did this impact the organization I was trying to secure? Spring 2015, March, April, May. I don't know if anyone else remembers, but spring of 2015 was when we started seeing like a massive kind of commercialization of ransomware that was being bought by people and sent out to people all over the world, right? People had their computers ransomed, entire networks and companies started going down, and this became kind of a pervasive problem, right? And so we felt this as well, being a big company with computers connected to the internet. So ransomware infections for us were a weekly occurrence in spring 2015, at least a weekly occurrence. And when I'm saying ransomware infections, I'm not talking about someone clicked the link and tried to execute something and it got intercepted by the antivirus. I'm talking about full-on infection, right? Like someone clicks a piece of ransomware, it starts connecting to network drives, and all of a sudden we need to contain massive amounts of computers. And it was to the point where we were spending 50 to 120 hours per incident, right? Not wall clock time, but in total time, because we would be 5, 6, 7 people trying to contain all of this and trying to make sure that we had everything. Someone would contact the AV vendor, make sure that we got new signature updates for the rest of the network, that sort of thing. And so containment, cleanup, restore, and retrospectives, we kind of got into the discipline of at least doing like a small retrospective, like what went wrong, what could we do to improve our incident response process the next time, because this seems to be a going thing. But again, 50 to 120 hours an incident, right? A week. What does that translate into? That translates into lost productivity on the floor, right? It translates into lost productivity because one user gets infected by a piece of malware, and all of a sudden you have 100 users or 2,000 users who can't access their files on a shared network drive. Okay, now we need to shut down or take offline all of these machines. We need to take offline the network share while we're restoring. People can still not access their files, and they can't really do anything, right? So like direct impact is lost productivity on the floor. And kind of the secondary effect here was that no one in IT support or in security could actually get anything done, right? We were chasing ransomware and cleaning up after it all the time. And so this kind of happened for a couple of months, and people were getting burned out, and we're like, we need to do something about this. And so my colleague said, I have an idea. What if we force the attackers to waste their time on systems that have no value? This is not actually what he said, but this is the only thing I heard when he said what I'm about to describe. So the system that he had come up with, this idea that he had was he was going to provision a Windows file server, just a VM somewhere, with 100,000 dummy files, right? JPEG files that in size look like they're probably vacation photos or something, but they're just gibberish. The same with documents, the same with Excel files, and so on and so on and so on. And so we ended up building a catalog of, I think, 17 or 20 file types that we had seen different types of ransomware specifically filtering for or targeting. And then we wrote a big PowerShell script that could generate gibberish files with these extensions. The next thing he suggested was, now we just need to turn on detailed file share auditing. You can do that with audit poll, you can do that with group policy, but what we wanted to capture was all the success events in this auditing category. Because what we want to be able to react to is ownership change or file write events to that share. Because what we're trying to do is get the ransomware or the attacker to target that share, right? So if any of these files change ownership or anyone tries to overwrite them or rename them or write to them, then that's probably a good indication that we have some ransomware going on. And so what we would do is we would take that event, we would have an event trigger, and then we would disable the owning account in Active Directory. We would disable the computer account in Active Directory. We would page the on-call for cleanup, restore, so on. And at the time, we didn't have any kind of good security or EDR orchestration in place. But would I have to rebuild this system again today? The first thing I would do would be to trigger automatic triaging and containment of this machine, right? So I'd ask the security agent I have on that machine to say, like, please disconnect this machine from the network and start collecting whatever data you can, so we can get some samples of the ransomware we've seen. Now, this is all fine and good. So we have a file server. What to do with it, right? We need some way of getting the attackers kind of onto our turf, right? We need to redirect and kind of shape their behavior in a way so that they hit this system before they hit our production network shares. And so how do you do that? Well, as I said before, we were doing retrospectives, right? So we were reviewing and kind of reverse engineering all the ransomware and all the malware that we were getting in during these attacks. And so what we noticed is that most of this ransomware enumerate mounted volumes via WMI or diskpart, or directly against the API that diskpart uses. And so there's one thing that kind of struck me when I started looking into this. These APIs always return the volumes in alphabetical order. And you might see where this is going, right? I'm going to ask a leading question. Is anyone using 2 floppy or diskette drives in 2015? you're using one, right? But you're not using two, right? So in the unfortunate event that someone was still stuck with a diskette drive in 2015, we're just going to mount on B. Now, what happened when we started testing this on a small subset of machines was that we would get a lot of false positives. And the reason for that is that users are curious. All of a sudden, there's a new B drive. Ooh, what's going on here? It's higher than C. I'm gonna have to check out what's here. So they would open the B drive. Ooh, pictures. Let me see what's going on here. Okay. So, what to do about that? And I kind of remembered in the back of my head, we had a customer once at my old job who wanted to do something similar, not for the purposes of ransomware mitigation, but they wanted write access to a share that was hidden in Explorer. There's a group policy setting for this. So the final touch of all of this, you simply use group policy. You could also have used the registry setting for this. You simply hide the mounted B drive from the user. So anyone who goes into Explorer and tries to see, they will just have their map network drives and their C drive, but they won't see the B drive even though it's there. But anyone programmatically trying to access the volumes on this machine is going to get B back as the very first result. And so the effect of this was that within a couple of weeks, we were down to maybe 5 to 8 hours of total like containment cleanup and so on. Like remember, we went from 50 to 120 to now maybe 8 hours, maybe 10 hours if the backups are slow. The other thing is we also got down to impacting only a single user. There's no more lost productivity in the floor because now we don't have 2,000 users impacted. We only have a single user that's impacted, whoever was unfortunate enough to run the malware in the first place. And we could start doing our jobs again. We could start building out some of the solutions and some of the detections we needed to the point where today we've actually retired this system because we don't need it anymore. And so 2 years later, in May 2017, we still had this in place. And we were doing like an all-hands security department thing, and someone asked, can you maybe go up and talk a little bit about ransomware? This was during the whole WannaCry crisis, right? All the big companies were going down, services were being lost, people didn't know what to do, people were working overtime. WannaCry was all over the place. And we weren't hit by it. The primary reason was not this system. The primary reason is that we actually patch. And so again, I can recommend you getting into better patching discipline. But someone asked like, yeah, but in general, like why are we not hearing any more about these ransomware things? It used to be a thing. And so I simply went up on stage and I told the story about the Cilician pirates and Caesar and bored a bunch of people to death. And they're like, this is fantastic. And so if anyone finds any inspiration in this kind of use case, feel free to hit me up on Twitter if you have any questions or musings about what else you could do with this. So to summarize very quickly, engage with empathy, become an enabler, and please value your own understanding of the systems that you're working with over the products that you can buy to manage them. And then finally, and this should be obvious to anyone at this conference, but PowerShell is immensely helpful for a lot of things, but for security delegation as well. These slides will be up later. I might add some samples of some of the systems here. Any questions? The later thing, yeah? Yes. How do I get it? You don't get it. We haven't published it. When is it going to publish? I don't know. That's an organizational problem. So yeah, I need someone to sign off on us releasing an open source version of that. But it is something we're pursuing.
Question about you're using labs to be able to use the local administrator password to be able to change the group membership of local administrators. Are you doing that because it's a round trip you can start from a client? Because you could skip the whole labs thing if you had an agent like SCCM or BigFix.
This is true. Yeah. You can do that as well. Right. So the question is, in this sort of setup, we're doing kind of a single round trip up to Active Directory to retrieve the labs password. As I said before, the idea of doing this was we had a number of the idea was to do it without introducing any more desktop management software, right? Like we didn't want to introduce any more new agents or any more new products, right? It's like, can we take what we have on the box and can we find a solution to this problem? One of the things that we've been looking into recently is changing this whole process to not expose the labs password. So instead, what you do is we've been looking into using GIA endpoints on the clients themselves. And so you might say, well, isn't it a server thing? Isn't that how you delegate DNS administration? And I think someone at Microsoft Germany says that's insane. But I will say this, this actually works really well. We deploy G endpoints on all of our clients for help desk management, right? So instead of help desk needing to use TeamViewer or remote assistance or something like that to remote into an interactive session on the box, they just have a little help desk application, and instead of direct calls against WMI or RPC, they just connect to a WinRM endpoint on the machine that they need to do something on, and they can do their diagnostics. What's better is that we can now start delegating tasks that would have required the user on the other end to be local admin in the first place. Now, only the G endpoint is the system, right? So we can say to the help desk operators, you don't need to be admin on anything here. You just connect remotely with your support applications. We can make the GUI for you. You can collect all of your information. You can do all of your troubleshooting. You can reset all the network interface card settings if you want to, without us giving you explicit access to that WMI namespace. And so what we're hoping to do is leverage that the other way around. So basically, the user sends a signal using this same application. We queue that request, and then rather than retrieving the Active Directory password, we ask another process to connect back to the WinRM endpoint on the machine and then make the local group membership change, right? The nice thing about switching to this, it becomes a little more complicated and a little more delayed, but the nice thing about doing this is that you can now start doing interesting kind of time-bound things in between. So if you have laptops belonging to people who you consider sensitive, right? Maybe the CEO, or maybe some of your smartest developers or your sysadmins, or the ones who have keys to the kingdom, right? Now you can start doing things like, instead of sending the lapse passport back, send an email to an approver or put something into a request queue somewhere, and then have the manager or the security department or a SOC analyst or someone else go in, evaluate that request, say accept, and as soon as you click accept, we connect back to the winner endpoint and make this change without exposing any credentials.
Two questions. How are you taking the interactive group out again? I mean, at some point.
Right. So I don't think I included this in the slides, but as I said before, we're relying on group policy to apply. Oh, sorry. Sorry. Can you repeat the question one more time?
The question was, how was the interactive group being removed from the?
Right. So the question is, as I said, we add the interactive label to the local administrators group, and how does that get removed again? As I said before, we run GP update before we make that change, and the reason for that is that we want to reset the refresh interval of the group policy client. And so 90 minutes later, or an hour if you've set the refresh interval down, the group policy client would kick in again. We have a restricted group policy setting in there that says the interactive should not be inside, and so it gets removed automatically after a set period of time.
Yeah, so you can think about the help desk, that's exactly what we wanted to do.
Excellent.
And then the other comment was around whitelisting, and the key to success with whitelisting is to start small.
Yep.
Pick a very important workload, do it in audit-only mode, get to the point where you get no exceptions, then go to enforce, and then pick the next one. Trying to do it for everything will just not work. And then the other key to success is to not have a server with trying to do a ton of different workloads. Take a workload, run it on a server. So we did this, Lee did a great job on this in Azure Stack, and we were successful because we had workloads on specific machines. So we knew exactly what that machine should do and should run, and worked very well.
Yep. So I completely agree, and this is kind of the same approach that we take to every kind of major change we make in this space, right? As I said, the local admin stuff, we started out testing it with 100 users, maybe got their feedback, kind of iterated on it. We're doing the same thing with privilege reduction on machines, right? Not just taking people's group memberships about, but also the assigned security rights, the application rights they have in Active Directory, delegations, that sort of thing. And it's the same thing. You pick kind of an interesting and high-value target. You kind of siphon that out from the mess you have. You solve that problem, and then you can go back and show, oh, there's actually value to be had here without us interrupting what you're doing. So yeah, absolutely a key to success. Yeah?
I missed the part about how you were able to retire the honeypot ransomware server. What was it that let you completely retire that thing and not get hit weekly anymore?
Right. So one of the reasons that we got hit Oh yeah. So right. So what is the reason that we were in a position to finally retire this ransomware mitigation system? We went back and we looked at, so in between 2017 and now, we also automated cleanup and containment to the point where none of us actually saw anything that was going on, right? We got to a point where we were spending maybe 15 minutes of someone in help desk's time doing the cleanup, right? And so at some point we had to decommission a monitoring system that was part in this whole orchestration deal, right? And we said, oh, we need to move this ransomware monitoring elsewhere. And someone had the audacity to ask the question, well, when is the last time this has alerted? And we found out that we've not actually used it for alerts within the last 6 months, I think. And I haven't looked deeply into why, but there's been a bunch of developments going on. Better discipline around coverage of things like anti-malware, EDR, right? So as I said before, we freed up the time to go back and focus on what the core of our job was, namely that we're covered in terms of, do we have antivirus everywhere? Do we have an EDR agent that can respond to these kinds of things? And so it would be interesting to go back and look at like the specifics and like when we started getting alerts for this. But I think I can pretty safely attribute it to the fact that we actually got back to the core of what does prevention and detection look like, rather than wasting our time cleaning up. Yeah?
You said patching is important.
Yes.
Besides patching, how important is,
Patching is clearly important. Besides patching, how important was it for you to keep up with Windows technology, to be able to support the latest?
I would say that is as important, right? You can kind of lump patching and what you might call Windows lifecycle management in together to a point, right? Because the same kind of organizational discipline that allow you to have kind of strict patching schedules and that you can actually report on being able to patch, critical vulnerabilities within so and so. It's the exact same kind of discipline that allows you to start upgrading to the newest version of Windows 10, right? So for me personally, it's probably more important than the rest of the IT organization that we get up to Windows 10. But as we're starting to solve some of these patching discipline issues at scale, IT also finds it way easier to catch up with Windows lifecycle management. So they kind of go hand in hand together. It's not like you need to choose one or focus on one. Again, kind of the organizational discipline required is the exact same. Yes?
If your organization has Office 365, you should consider using OneDrive because it detects and protects against ransomware, and it's awesome. It really is fantastic.
Right.
I got a new gig with Office 365.
Do we have any more plugs? Any more? All right. If not, my name is Mathias, and I want to thank you for coming to this talk, and I hope you found it interesting.